Hello everyone, my name is Atish and topic of this learning video is linear dependence and linear independence of vectors by matrix method. In the last lecture we have seen the same topic by with the help of Cramer's tool how we can get the linear dependent and independent of vectors and the relation between them. In this learning video we are going to start with the same topic but by the different method. Okay. So let us start with the basic terminologies. The terminologies, a few terminologies will be same as the previous that we have in the previous video, like vectors, linear combination, linear dependent and linear independent of vectors. Now the new thing is rank of a matrix and consistency for homogeneous system of linear equations. Now, what is vectors? We have already seen these three definitions. So, just a revision of class. An ordered set of n numbers x1, x2, xn is called a vector. We denote the vector by single capital alphabet. Here x is equal to x1, x2, xn is a row vector, and when you take a transpose of it, it is nothing but a column vector. Okay. Now the next thing is linear combination. What is linear combination? Some set of vectors will be given to you, and for these set of vectors there exist exactly same number of scalars. Then the vector formed by these vectors and scalars is called a linear combination of x1, x2, xn. The next definition is of linearly dependent. The set of vectors x1, x2, xn are said to be linearly dependent if there exists scalars k1, k2, kn not all 0. You know the meaning of not all 0. Not all 0 means at least one scalar should be non-zero such that the linear combination is equal to 0, where this 0 indicate the null vector or a 0 vector. Now in the last interaction I asked you the definition of linearly independent and you were very smart in giving the answer to this question. What is linearly independent? The vectors which are not linearly dependent is linearly independent. Simple. And then we have a mathematical definitions. The set of vectors x1, x2, xn are linearly independent if and only if linear combination is equal to 0 implies all the scalars must be 0. Okay, now here comes the new thing that we really want in this learning video, rank of a matrix. So you are very much familiar with the rank of a matrix. If anyone asks you what is rank of a matrix, you are capable enough to answer this question, that is the number of non-zero rows after applying the elementary row or column transformation to a matrix is called as rank of that matrix. And as far as the notations are concerned, these are the notations: row of A or R of A or simply rank of A. So these are the notations for the rank. If you want to learn more about how to find out the rank of a matrix, we have a link in the description of this video. You can just click on it. It's just an 8 to 9 minute video. You can go through that video and you will able to see how elementary row and column transformations are used to get the rank of a matrix. Okay, now the next thing. Now the next thing which is important is consistency of system of linear equations. Whenever we talk about the consistency of system, so we have two types of system. One is homogeneous and another one is non-homogeneous. The system you see in this slide is a homogeneous system because for the non-homogeneous system we have, instead of 0 we have some scalars, say b1, b2, bm, but for the homogeneous system we have always 0. Okay, so this is nothing but a homogeneous system. So this system will be consistent, meaning thereby this system possesses a solution if the rank of coefficient matrix and the rank of augmented matrix are same, or in simple words you can say A and C will have same rank, then and then only the rank, then and then only the solution is possible. Okay, now let's see how to check consistency. Okay, now you have matrix A, you have matrix C, augmented matrix C, and now you have to see whether this whether the system will have a solution or not. So this depends on, very much depends on the rank of A and C. Okay, so the very first condition is, if the rank of coefficient matrix A, that is R, and the rank of augmented matrix C, that is R dash, if they both are different, then the system is inconsistent and have no solution. Okay, now the case we are discussing in this learning video have must always have a solution. Can you answer me about that? Because as you can see, the coefficient matrix and augmented matrix are more or less the same. The only thing is just the addition of 0 column to this matrix, and addition of 0 column to the matrix means nothing. Means here whenever you have a homogeneous system, means the coefficient matrix and the augmented matrix are same, and you will always get a solution in the homogeneous system of linear equation. Okay, so this is the first one. The second condition is rank of A and rank of C are same and it is equal to the number of unknowns. Okay, so in that case you will be having a unique solution. Only one solution will be getting, and that would be a unique one. Okay, and can you predict the another possibility that we have left out? We have rank not same, rank same and equal to n, and the third will be rank same but it is less than the number of variables. Okay, then still, because rank of A is same as rank of augmented matrix, still you will be getting a solution. But if the rank is less than the number of unknowns, then the system will have infinite number of solution. I'm not saying infinite solution, there is a huge difference between infinite solution and infinite number of solutions. So you just take care of this thing in your mind, that this is infinite number of solution. Okay, so in such case what we have to do, we just have to assign arbitrary value to n minus r unknowns and express other unknowns in terms of the n minus r unknowns. Okay, so these are just the revision. We have already seen these things in previous semesters or in the previous classes. Now the working rule. Why we are why I am putting working rule in our slide, because sometimes what happens in the exam time, student don't have time to revise all those things. So this working rules, in every slides you will find working rule, and the motto behind writing down or explaining the working rule is, in less time you will get the maximum output. Okay, so let us see the working rule. Write down the given vectors as previous, then write down linear combination equal to 0. Okay, the first two steps is same as the previous topic. Now here comes a new step. Write in the matrix form Ax is equal to b. So you have to write down the system in the form of Ax equal to b, and then you have to apply elementary row transformation to reduce a matrix A into upper triangular matrix. And once you reduce the given matrix into upper triangular matrix, you can certainly talk about the rank. The number of non-zero rows of a matrix is nothing but the rank of a matrix. Then we have to check for the consistency. Depending on whether the rank, we will always be getting solution in this case because we have homogeneous system. Okay, so if the rank of matrix, augmented matrix, and rank of matrix A both are same, then either you will get the rank equal to the number of unknowns, or you will get the rank less than the number of unknowns. So as per the case you have to apply. Okay, and at last we'll be putting all the values in ax equal to b and solve this equation to get the answer. Okay, now let us take an example. Do you remember this problem? This is the same problem we have taken and we have solved with the help of Cramer's rule also. Okay, so the reason behind I'm taking the same example is that just want to see whether we are getting the same answer after applying to different method. The same example we have taken in the last video by Cramer's rule. Now we are taking the same example with the help of matrix method. So now we'll see whether we are getting the same answer from different methods or not. Okay. So the example number 1 says, by matrix method check whether the following vectors x1 1 2 4, x2 2 minus 1 3, x3 0 1 2, and x4 minus 3 7 2 are linearly dependent or linearly independent. So this is the first thing that you have to check, whether the vectors are linearly independent or dependent. And depending on the first part, you can talk about linear combination, whether the linear relationship exists between the vectors or not. Okay, so let us start with the solution. So what is the first step? You have to write down the given vectors. Okay, and after writing down the given vectors, you have to take the scalars. How many vectors are there? There are 4 vectors. So how many vectors one should take? 4. And how many I have taken? I have taken 3. So just need to add one more scalars, k1, k2, k3 and k4, such that the linear combination equal to 0. I have written the linear combination correct, just k4 is missing in the sentence. You should not miss. Okay, in the examination it is expected from you to write down. Okay, so say this is to be equation number 1. Now substituting the values of x1 1 2 4, x2 2 minus 1 3, x3 0 1 2, and x4 minus 3 7 2. Okay, now what is your next objective? Your next objective is to solve this equation. So how many equation you'll be getting? You'll be getting 4 equations. And which are those 4 equations? Sorry, you are getting 3 equations in 4 unknowns. So the first equation is k1 2k2 0k3 minus 3k4. Again a printing mistake, it should be k4. Likewise, you solve the second and the third equation, you'll be getting this. I hope I have written the equations correctly. Yeah, so these are the different equations we are getting. Okay, after getting these equations, this you have to write down the given equation of the form x equal to b. So here it is. Now what you need to do is, after writing down the system, you just need to write down the augmented matrix, and augmented matrix will be same as the coefficient matrix A. The only change is there is an involvement of column matrix. कुछ लोग होते हैं ना ऐसे, those are good for nothing. So this column matrix is playing a role like good for nothing. Okay, so let us see, we have the augmented matrix. Now we have to reduce it to a upper triangular matrix. So what are the targeted element? 2 4 and 3. So these are the targeted elements. So can you tell me to make it, so we have to make these 3 elements 0, and to make this element 0, what would be your elementary row transformation? So just pause the video for a second and come up with your answer. We have to make this position and this position 0. Okay, so just pause the video and think over it and just let me know the elementary row transformation. I hope you have written the row transformation to make these two targeted positions 0. So to making R2 0, you have to change R2 changes to R2 minus 2R1. And I know you might, you all have written, or you all uh, have written the same thing. And to make the third row 0, R3 changes to R3 minus 4R1. Okay. Now once you make these changes, we'll be getting this matrix. Okay. Now these two are 0, so only thing we need to do is we just need to make this one 0. So how one can make this 0? Can you tell me the row transformation? Yes. How? You just make this 0 by subtracting this R2, by subtracting R2 to this R3. Okay, so what is your row transformation? R3 changes to, not R3 minus 4R1, it should be R3 changes to R3 minus, what is it, R3 minus R2. Okay, God knows what I have did. I will just copy down this one here, need to edit this one. Okay, so after applying the condition, what you'll be getting, you'll be getting 0 0 0, these three, and some changes here. Okay, now how many unknowns we have in this equation? We have 4 unknowns. Okay, now can you say the rank of this matrix? The rank of this matrix is 3, because there are 3 non-zero rows, and number of non-zero rows equal to the rank of the matrix. So the rank of the matrix A is, neglecting this, rank of the matrix A is 3. Now when you add this, rank of the matrix C is 3. So rank of A, rank of C are 3, and number of unknowns 4. So what you can say, R equal to R dash is less than N, because 3 is less than N. So what, so we falls under which condition? We falls under the condition third one. Okay, and the third condition says the system has infinite number of solution, and if the system has infinite number of solution, the given vectors are linearly dependent. Okay, so just need to remember one remark. The remark is infinite solution linearly dependent, unique solution linearly independent. Okay, so these two things you have to remember. I will ask this question during the interaction. Okay, now we have whatever we have found out here, you have to put this equation in the equation or the matrix form Ax equal to b. Okay, so we have matrix after row transformation, and now you have to solve this. Okay, so we have 3 equations and 4 unknowns. बहुत ही नाइंसाफी वाली बात हो गई फिर से. So what we'll do, we'll take n minus r. What is n? 4. What is r? 3. So n minus r, so 4 minus 3, 1. So I need to take one vector as arbitrary constant. So I will take k4 as c. So let us take k4 as c. Okay, now I will put the value of k4 as c in equation 3. I will get k3 as minus c. Now I have k4 and k3. I will put it in equation 2 to get the value of k2, and the rest of the values in equation 1 to get k1. So equation 2 implies k2 is 12c by 5 and k1 implies minus 9c by 5. Okay, now after getting these values of k1, k2 and k3, you need to put these values of k1, k2, k3 in equation number 1. So in the very starting we have na equation number 1. This equation I am talking about, this one. So we got the values of k1, k2, k3, k4, and we have already seen the vectors are linearly dependent. How it is linearly dependent? We have a justification that the rank of matrix A and the rank of matrix C is not same. is the same but is less than the number of unknowns. Okay, so we have to put these values of k1, k2, k3, k4 in equation 1. Will get where it is. Okay, we'll get the answer k1 minus 9c by 5x1 plus 12c by 5x2 minus value of k3 is minus c and value of k4 is plus c. Okay, now this doesn't look good, isn't it? So what you have to do is just multiply the entire equation by minus 5. So minus will get cancelled, 5 get cancelled, it should be minus 12, this should be plus 5 and this should be minus 5. Okay, so this is the linear combinations we get in this example. So we have taken the same example with the help of Cramer's rule, and as you can see we got the same answer as in the problem that we have solved with the help of Cramer's rule and the problem we have solved with the matrix method. So irrespective of what method you apply, whether a Cramer's rule or matrix method, you'll be getting the same answer. But it's a suggestion from my side that whenever you are applying whenever you are solving example on linearly independence and dependence, you should go with the Cramer's rule because it's very easy and the small solution is there as compared to this solution. But this but is very important. But if it is asked in the examination that you have to write down, you have to solve the problem by matrix method, then you have to opt for this method. Okay, meaning therefore it is necessary to learn both the methods. Okay, so again we'll be having some try this at home problem. So we have problems by matrix method, you just have to go through and same problem you have to apply. I'm not going to say anything about this problem. ओके ओके सम मोर प्रॉब्लम्स. अब आप बोलेंगे सर 2 के बाद आता है 3 और आपने लिखा है 4, सो इट्स एन एरर मिस्टेक, इट्स अ एरर, यू कैन अंडरस्टैंड, just think of it as 3. Okay, so that is what we have in this learning video. So happy learning digitally and thank you for watching this learning video. Thank you.